Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Super, and today we're going to be focused on an Azure Virtual Desktop incident. This happened within multiple regions within the United States. It occurred on the 16th of September, and it was approximately 2 hours in duration.
So with that, we'd like to introduce our speakers, our engineering leaders joining us today to explain the impact and our learnings. First up, we have Rajesh Dadia, our Vice President of Engineering from the Azure Virtual Desktop team.
And joining us as well, we have Naveen Prakash, our Vice President of Engineering for Azure SQL Database.
As you'll see, AVD and SQL were the two different kinds of sides of the coin for this incident, since Virtual Desktop relies on SQL for some important data storage. Rajesh, since you're representing Azure Virtual Desktop here, and that was the pain that customers felt, I wondered, could you help us understand the post-incident review talked about impact to the US geography. Now, does that refer to where users are based or where customers choose for their configuration or for their host pools? Can you just help us to understand the blast radius first and foremost?
Absolutely, David. So before I talk about the impact, I also want to give the overall lay of the land in terms of how AVD, the service, is architectured. So fundamentally, there is AVD is a geo-based service. It is operational in geos such as US, Canada, EU, and so forth. And with that model, what it does is it gives customers, a primary sort of ability to operate at that geo level and configure something what we call as host pools. Host pools are essentially these objects within AVD that actually define the realm for the pool of backend VMs or machines that you're operating on, and they are configured together as part of the host pool. The host pool itself is pinned or pivoted essentially to geo, but the VMs that are part of those host pools can be scattered in any region worldwide. And so therefore, the users, when they actually are trying to use their personal desktop or a pool desktop, they have the ability to come from anywhere, and we support the model where users can actually log in from anywhere in the world, but they will be routed to their backend personal desktop or pool desktop based on the host pool configurations. So in this case, the US geo was affected, and US geo essentially serves multiple regions, and so therefore this particular outage was a multi-region impact outage for us.
Got it. That's helpful to understand the blast radius. And Rajesh, what would the impact during this incident actually have felt like for customers? It wasn't a hard down outage for everyone using Azure Virtual Desktop. So this was just affecting new connections, right?
Yeah, so primarily, I think AVD backend services have two, I would say like 3 to 4 different roles, I would say. But the two of the fundamental roles are essentially a broker and a gateway. Broker is our orchestration backend orchestration service. So think about it this way: when a user logs in and they want to be connected to their personal or pool desktop, they log into the system, they authenticate, and it's the broker service that actually helps find out, where their personal or pool desktop may be that they need to be routed to. Once that orchestration happens, the gateway service takes over, and then it maintains a backend connection. And so in this case, the database that was impacted was connected to the broker, and so the orchestration piece was affected. But the existing connections that were established, through the gateway, they continue to work. Yeah.
Super, thanks very much. And Naveen, if I can turn my attention to you. In the PIR, we stated that one of the initial conditions is that contributed here was a SQL redo process degrading. The redo process, I understood it like a replication process, but maybe you can understand, first of all, what it is, how it should work, why it degraded as well.
Okay, so databases usually have 4 replicas to provide the high availability that a customer needs. So the way it works is there's one primary to which you are connected and where you write. And then when you write in databases, you generate logs, and those logs are shipped to 3 of the other replicas. So what we do is we harden the log first, and then in a separate thread, we redo. The reason we separate these two so that the commit is much faster, and OLTP and all these operations, they need a very fast commit. So we harden and then we redo. So on these secondary replica, when we redo, it needs to keep up with the log generation rate. Otherwise, this lag will become bigger and bigger. And when we are not able to keep up, other things happen. Like in this case, there was one store where we maintained the versions on the primary, which kept growing. And then this hurts the performance on the primary workload. And this is when the AVD observed the degradation in performance, and the AVD's customer observed degradation of performance. And so this is why a redo lag causes a degradation of performance on the primary. The reason we keep the redo together, because they could be a failover target, and we want to make sure that as soon as we failover, the primary workload is up and running in no time.
Super. And then if we could double click into what actually caused, or what were the contributing factors that caused this lag to happen as well.
Yeah,
Okay.
Naveen, as you were talking about it, it made me think, it sounds like you're saying that some level of lag is inevitable, that sometimes there is lag introduced, but this was worse lag than usual, is that right?
Correct. So we have seen redo lagging in other situations, and also when the log generation is very high, we have seen redo lag, and we have had plans to go and improve these redo lags, because this redo lag is never good. It not only causes unavailability, which was the case here when it was picked as a new primary, but it also causes staleness of query results when queries are run on the secondary. So redo keeping up with the log generation rate is P0 for us. It's very important. And we had planned work to keep improving redo so that it keeps up with the log generation rate. In this case, the log generation rate was around 45 Mbps. Our expectation was that redo should be able to keep up with it. When we went and looked inside and why the redo was not able to keep up with, we found a contention that we had not seen in the past. And that's why this was a pre-existing bug, which just showed a pre-existing contention that showed up. There was no new regression or no new binary that was done. So we identified where this contention was, and this is one of the repair items that we talked about in the PIR.
Got it. That's really helpful to understand. So generally speaking, this redo lag was already a known issue, was already something that we're working to minimize. But as a result of this incident, we learned something new. We learned about that contention, and now we can do even better at addressing that redo lag. Great to understand. Thank you, Naveen. So Rajesh, maybe back to you. Initially, when you all detected issues, your monitoring kind of was aware that there was something bad happening, but customers weren't hard down, right? And so I wanted to understand, what did you detect, and when you initially involved the SQL team here, that there was no customer impact, there was some customer impact, and then later in the story, it sounds like we made things worse.
Yeah, no, I think that's a great question, David. I think, so we, as part of any scalable, like any scalable cloud service, we aggressively monitor the health of our service on all fronts. And one of the indicator that we also monitor is that we make sure that the replicas, the SQL replicas that are essential, for our regional failover, they are always healthy. And many times, actually, we redirect some of the read-only workloads to these read-only replicas. And so as part of that, it's essential for us to monitor that replica is in sync. And when it gets out of sync beyond a certain threshold, we start actually firing alerts, and we start attending to those. So as on that particular day, we started observing that, and we started engaging basically, with the SQL team to understand what could be the cause. And as the time progressed, we started also getting some customer complaints around customers trying to configure, objects, through portal, storing them, in the write-only database, but the read-only workload that was directed to these read-only replicas, it was falling behind. So when you were doing read after write immediately, you could see essentially some configuration mismatch, and we started looking at those complaints. But then it's the replay of this progressively started getting worse at a point, where we needed to sort of understand, what are the mechanisms we can now deploy, to catch up. And that's when I think we started working very closely with the SQL DRRIs.
Super. That's super cool to understand that we're monitoring well before customer impact and we're kind of doing work in the background. Naveen, given those conditions, I understand that the trigger event was us trying to mitigate the lag in the read-only replication. But by triggering this failover, could you tell us what should have happened and then what actually happened?
Okay. So what actually happened was when we got engaged, we saw performance on the primary dipping, and we saw the lag, but the DRI unfortunately could not distinguish between what is the cause and what is the impact. The DRI thought the slowdown on the primary is the cause of the redo lag, and instead of removing the replica which was lagging and letting another replica to seed because we had two other replica, they killed the primary. So when they kill the primary, the new primary needs to be elected. And again, the second unfortunate thing happened, and this is like how the primary election happens. We picked the replica, which was already lagging. Now, once that is picked as a primary, the problem is it needs to catch up before it can be opened for the primary workload. And at that point, after some things, the DRI realized that that was not the right action to take, and they removed this replica, and the new replica, which was caught up, became the primary, and the work resumed. So the time it took for us, first of all, we could not detect. We should have detected the redo lag, and then the action that we need to take was incorrect. So that is the learning for us, and that's what we'll follow up on.
Got it. That's helpful. Now, both Rajesh and Naveen use an internal acronym here, DRRI. We use directly responsible individual. That's just our on-call engineers. So we're referring to our on-call AVD engineers and our on-call SQL engineers. I'll translate for you all. Okay, so that's a good way to understand kind of what happened, what went wrong. I understand that once we had realized that failover has caused problems, Naveen, how did we go about actually investigating and mitigating that issue ourselves? Did that take time, or was that something that we just kind of waited for things to catch up? We didn't actually need operator action to mitigate it.
So in the beginning, we were just waiting for things to catch up, and that's when we were facing the unavailability until we realized that we can just remove that replica and rebuild the new replica. So that's again DRI or on-call engineer education that we need to do.
Got it. That's a great segue here, because I would now like to turn to our learnings and repairs from this incident. And I know each of Virtual Desktop and SQL have some learnings and repairs here. Naveen, starting with the SQL side of things, in our post-incident reviews in Azure, we always try to resist framing things as human error, right? Instead, we want to try to frame it as, how did our systems allow that operator action to result in customer impact? If an engineer triggered some kind of unexpected outcome, that's obviously a signal that our system or tooling, didn't give them sufficient visibility into what was happening, or that we lack the right safeguards. So given what you're talking about in terms of choosing that secondary, how do we improve here?
Yeah, you're right, David. Human error will always happen. However much we train, there will always be a scope for human error. So it's always good to rely on the system to prevent those human errors. So first of all, we were missing our own alerting. We had to rely on AVD to inform us that something is wrong with the system. So we are adding alerting that whenever the redo has fallen behind a lot, we should be alerted. The second thing is the check when we fail over. Those checks needs to factor in that replica is lagging, and if we fail over, if the lagging replica can be picked up, and that becomes the primary causing this unavailability. So we want to put that check in the tool that was used to cause this failover. And besides, we already talked about, we want to improve the redo process so that we never get alerted, DRI never has to call, and the system just works beautifully as it's supposed to without any lag.
Got it. That's great to hear in terms of our on-call processes and what happens when we jump in to help mitigate things like that. How about in preventing that kind of redo lag, like you mentioned at the end there? The post-incident review mentioned a repair item and a new feature. Is that what you were just talking about, or is that something different?
So that's correct, David. So as I said in the beginning, when log generation rate is high, I want to make sure that redo is able to keep up with this. So that includes the repair item that we discovered from this incident, which we have already prioritized, and the bunch of other work, and these are like some hard engineering where we want to make sure the redo keeps up with the log generation rate. And those improvements we should be able to see will light up gradually. It's not all or nothing, but those improvements will light up, because to give more insight into what we do is, when we read the logs, we chunk those logs and give it to the workers, which will go and read those logs and replace it on the pages, so to bring it up to where the primary is, and then they checkpoints the pages. Since this happens, so the logs are generated on multiple threads on the primary, but here there's only one redo worker trying to do the work for various connections that were on the primary. So we need to make sure that we can scale this operation. We can do the updates in the same rate at which it was being done on the primary. So those are all, there is a lot of improvement we've already done, but there are a bunch of improvements that we are doing, and they will light up gradually as they get done.
Super, thank you. One of the things I always find interesting is we know that outages are inevitable, but we always say that impact doesn't need to be. And one of the reasons this was such a big deal is because this was a multi-region impact, and multi-region impacts are very painful for our customers. And so, Rajesh, if I can turn my attention to you, in the repair items for your team, how do you plan on improving your geo failover, and how do you, and for your DR strategy, what are the steps you're taking so that it's not a multi-region outage?
Yeah, absolutely. Great question. So I think, first of all, what I'd like to say is that we today operate, SQL in a very high availability mode. Not only that we have, regional replicas, but we also have geo replicas, and then we have processes in place actually to fail over to those geo replicas as and when needed. Having said that, I think there are clearly a lot of learnings that we have taken from this incident. First of all, we realized the responsibility we bear in terms of making sure that customers, when they want to, during work hours, when they want to get to their cloud desktops, they can actually do so with confidence and with very high availability and reliability. So to that effect, we have started looking into what are our essentially, failure points more closely. Connection orchestration, as I mentioned, that's a function of broker, is a very, very important function. And I think we want to keep very high availability as well as reliability for that function. So to that effect, we are taking several repair items and several action plans. Firstly, I think we are looking at segregating some of the workload, that today falls on the central database, for every geo. And so in that, we are looking at separating the diagnostics workload, for example, that is currently, tied with the operational database that we have. And so we have steps in Sept's plan, to actually get to the point very soon, where we'll actually reduce the overall workload on the operational database. Further, we are also looking at some of our volatile data, that actually is stored, during the connection establishment phase, from the configuration data, so that we can actually segregate these two processes further and create better scale points, for the backend store. And the third thing that we are looking at is employing more caches. Are there places where we can actually do more caching of this data, that can come handy, where for a certain duration, our primary database is not available. We already do a good amount of caching in the backend, but in this connection establishment path, since so many of the flows are tied to user authentication, we need to make sure that, whatever we do here, is secure. So we are looking at those strategies as well. And lastly, what I would also mention a couple of other things. One of them is we are looking at a model, where we can provide more regional redundancy through creation of these host pool objects, on customers' behalf that can be pinned to a specific region. Today, the model is designed per geo based on the flexibility that it provides to the customer in terms of, creating these host pools on a per geo basis and not worrying about a particular region. But we're also looking at a model, where we can introduce host pool specific host pools that are specific to a region. And lastly, in our process, one of the things that we are going to take a deeper look at is our GeoDR strategy. Today, our GeoDR is designed actually to do graceful failovers that prevents data loss of any kind. And so we prioritize data loss over availability. I think there are certain workloads, as we segregate these workloads, I think we have an option to do provide more availability, higher availability, and not worry so much about, the data loss in those scenarios, especially, where the data itself may be volatile, So that's something that we're going to look at deeply, where we can do forced failovers, compared to the graceful failovers that we do today.
Magic. Thank you very much. There's one other piece I wanted to pick up with you, Rajesh. I think the next day I was on call for comms, and there was an incident, and I was called to the bridge, and I think you and I are working together, and you were speaking about how Azure Virtual Desktop is going to disable some of the telemetry logs being uploaded as a temporary measure, and we sent communications, we referenced this event, but could you tell us a little bit about that? Like, what's changing now for customers using Azure Virtual Desktop from the day before of this incident to the day after of this incident?
Yeah, so that's a good question again. I think one of the things during the response we wanted to ensure was that we make sure that the essential workload has a better line of sight to the database first. And what that means is that, again, going back to the connection orchestration, that phase we wanted to protect. So we wanted to, as part of protecting that phase, we wanted to disable non-essential workloads, such as the diagnostics workload. And the diagnostic workload itself is actually made up of multiple parts. So there is connection telemetry, there is management telemetry, there is other types of telemetry that we continuously sort of capture. And what we did was, as the first step, we actually disable all telemetry to make sure that the connection establishment is successful. Once we got the confidence, that the database primary was able to recover and was able to support a sustained load, that's when we actually reintroduced the connection telemetry, which is what we as well as the customer care about the most. And then we started looking into other forms of telemetry. But as a precautionary measure, we wanted to make sure that, we don't reintroduce all the telemetry all at once,
Well, that's great to understand. Good that you two happen to be on call at the same time, which is a good segue because Sammy runs our incident communications team. So at this point in our live streams, I like to turn to Sammy and ask, how did we do? How did we do in terms of our communications? Did we keep customers up to date? Where do we have any learnings from a communications perspective?
Super, thank you. So when this incident happened, we communicated an hour and 15 minutes after customer impact had began. One of the reasons it was quicker than other times is because there was work going on previously. Now, we communicated directly to impacted customers through the Azure Management Portal. So if customers had service health alerts like email and SMS and webhook set up, all of those would have fired, albeit just over an hour later. What was interesting is we sent a resolved communication and we put it on our status page. And looking back, I'm not sure if that was the right decision to make. Number one, the incident was mitigated, but we understand that customers like to point their customers to something to say, look, it's not an us problem, it's an Azure problem. And so sometimes I feel like the criteria for the status page we've made it very public to say, hey, these are the types of things we'll publish there. I don't know if this is the kind of thing that would belong there because every customer who was impacted was receiving communication. It was behind the north wall, but we were able to communicate to impacted customers. But again, we went to that status page after the fact. One of the things we'll be doing is we have our Brain, which is our automated communication mechanism. It communicates to impacted customers within 15 minutes of impact. This service and scenario is not onboarded onto Brain, but we'll go and evaluate, hey, what's the likelihood of this failing again? What is the blast radius? How painful is that? And we kind of aggregate all of that and say, should we onboard this to Brain now, or do we get to defer it because there are other scenarios that might take priority? But that's kind of how we did with the communications.
Got it. So it's a little bit delayed there for an hour, but everybody who was impacted was getting those communications in the portal. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.